In this example, we're going to be solving a radical equation, and the first step is to make sure the root is completely isolated, and it is. It's isolated on this left-hand side. So we're ready to get rid of the root. Remember, every square root has an index of 2, so the opposite of square rooting something would be raising it to the second power. If I raise the left side to the second power, I have to raise the right side to the second power. So what's left is 30 minus 2x on the left side, and I have x minus 3 squared, so that's x minus 3 times itself. So I'm going to simplify the right-hand side by distributing. So distribute the x to both terms. So x times x is x squared. X times negative 3 is negative 3x. And then I have to distribute the negative 3 to both terms. So negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So on the left-hand side, I still have 30 minus 2x. And on the right-hand side, I can combine my x's. Negative 3 minus 3 more would be negative 6. So I have x squared minus 6x plus 9. So in order to solve this, I noticed that there is an x to the second power, which means I need to get everything to the side with the x to the second power. So I need to move the 30 and the negative 2x over. So I'm going to move both of those all at once. So I would subtract 30 and I would add 2x to make a 0 pair on the left side. And if I do that to the left side to get 0, I would have to do the exact same thing to the right side. So subtract 30, I'm going to put it under the 9 because I know those are like terms, and I have to add 2x. And I put it under the negative 6x because those are like terms. So on the right-hand side, I have x squared. Negative 6x plus 2x is negative 4x, and 9 minus 30 would be negative 21. Now from here, in order to solve this, I'm going to try to factor. So for our factoring method, we're saying what multiplies to the back number, negative 21, and adds to negative 4. So the factor pair that works here is negative 7 and positive 3. So this can be factored. So the two factors would be x minus 7 and x plus 3. From here, we apply the zero product property, where you set each factor equal to 0. So set x minus 7 equal to 0, and set x plus 3 equal to 0. So if we solve these, we get x is equal to positive 7, and x is equal to negative 3. So we do need to check for extraneous solutions, so we're going to go back to the original equation and plug in 7 and make sure we get a true statement and plug in negative 3. So let's check x equals 7. So I'm plugging in 7 for x and make sure we get a true statement. So 30 minus 2 times 7, plugging in 7 for x, is equal to plug in 7, so 7 minus 3. So the square root of 30, negative 2 times 7 is negative 14. That has to be equal to 7 minus 3, which is 4. And this is true because the square root of 16 is equal to 4. So x equals 7 is a true solution. Now let's check x equals negative 3. So plug in negative 3 for x. So I would have 30 minus 2 times negative 3, and that should equal negative 3 minus 3. So this is the square root of 30, and negative 2 times negative 3 is positive 6. And that's equal to negative 3 minus 3, which is negative 6. And I could see that this is not going to be true because the square root of 36 is not negative 6, it's positive 6. So this is an extraneous solution. So the only solution here is x equals 7.